at this point, we've discussed a little bit about bonding, or at least you have with your instructors. I am concerned now about how these bonds are represented and demonstrated in our molecules. And so the easiest way that we can demonstrate those is by drawing Lewis structures. Now, Lewis structures by themselves are three-dimensional molecules that we put onto a two-dimensional page. So drawing them can be pretty simple as long as you follow certain steps to do so. You're going to add up the total number of valence electrons from the atoms in the formula. You're going to look up your EM values for each atom, whatever you have as your lowest electronegativity value, except hydrogen will go in the center. If for some reason there are some atoms, like for instance chlorine and nitrogen, that are in the same electronegativity value, we'll see that should be that they'll end up we'll just choose the one that has the least number of valence electrons. Then draw a skeletal arrangement. Add lone pairs of electrons on the outer atoms to satisfy your octet and duet rule. Now we're going to talk about the octet and duet rule in a minute. One minor caveat here, you cannot use more electrons than what you calculated for in step 1. So if you're using more than that number of electrons, which you shouldn't, it means you probably didn't calculate something correctly in step 1. Then you're going to check to see if there are 8 electrons on the central atom. If you do not have enough, and these are kind of you do at the same time, you check to see if you have the same total number of electrons that have been used. If there's too few, you add lone pairs. If it's enough, you're then going to add more lines to create double and triple bonds. So let's do this talking about the octet rule. With our octet rule, most atoms have a tendency to have 8 valence electrons in their shells. That means that we need to have a total of 8 valence electrons. If a bond counts for 2, then we can have 4 bonds, or 8 sets are 8 lone pairs, or 4 lone pairs, 8 electrons. Hydrogen and helium, they only want to have 2. Helium doesn't react with anything, so realistically, duet rule only applies to hydrogen. So let's look at our structure here. We have C, that is going to give us 4 electrons. We have H, that gives us 1 electron, and we're going to multiply that by 3, so we get 3 electrons from our hydrogens. And we have chlorine, which is 7 electrons. Add these together, you get a total of 14 electrons. Now, looking at the electronegativity chart, you're going to see that carbon should be in the middle. So that's what we're going to do. We're going to draw our skeletal arrangement. And we're then going to add 6 electrons, or 3 lone pairs, to our chlorine to satisfy our octet rule, because now we have 2, 4, 6, 8. So we now need to check to see if we've used 14 electrons. 2, 4, 6, 8, 10, 12, 14. And carbon has 8 electrons on it because it has 4 bonds. So this is a good check. Now, when we talk about these valence electrons, we're really going to be talking about their three-dimensional structure, which we draw on a two-dimensional. So when I look at my three-dimensional shape here, this is what I've done in a molecule drawing. I have my black carbon in the inside, my 3 hydrogens are the white portions, and I have my chlorine on top. So even though I drew it like it was a cross on my paper, realistically, it gives a little bit different of a structure. This leads us into the idea of molecular geometry, and that's determined what the shape of the molecule is. So we had in our situation with our Lewis structure we drew that it didn't really give us a cross shape. It was a little bit different. And that occurs because of this idea of the valence shell electron pair repulsion. And that's the idea that as you have electron pairs around the central atom, they're going to move as far away as possible from each other in order to balance out, because the fact of the matter is that negative charges are repelled. So we have our examples here of our molecular geometries. When you're drawing these Lewis structures, the easiest thing to do is to count up your number of bonds, your number of lone pairs. So if you have 2 electrons, that's 1 lone pair. And then you can figure out your molecular geometry from this chart. So if we looked at our drawing we did for CH3Cl, we're only going to be looking at the central atom, because the central atom is what determines our molecular geometry. So we have 1, 2, 3, 4 bonds and no dots on carbon. So we should have 4, 0, and it becomes a tetrahedral structure, which matches the picture right here that we had when we put them as a molecule set. Hopefully this explains a little bit more about molecular geometries and Lewis structures so that you can understand how this affects polarity and the properties of a molecule.